So now for question B, increase the temperature at 3, meaning they add superheated the steam to become T3 equal to 600 degrees C. Oh, that's very high, and that's very high. I mean, you know, in the theoretical class, I mentioned that usually 650 degrees C that the turbine blade can take a normal power plant, normal steam power plant. In this calculation, we want to see if we have 600 degrees Celsius at point 3, what will happen to the thermal efficiency. So to calculate this, we again the same steps. We have to get the enthalpy for each point. So point 1, point 2. If you realize point 1 and point 2 is exactly as point 1 and point 2 in the question A. So question A, we can just exactly get the H1 and H2 exactly the same. So we don't have to bother to calculate it, but we can calculate for I mean, you get this from H1 and H2. Look at this. So we have H1 and then we have H at 2 with this one, and even we have everything from point 1 and point 2. However, for point 3 we have to calculate sebab point 3 dia dah tukar. So point 3 pressure, pressure still 300 megapascal, but the temperature is 600 degrees C. So we refer to what table? Refer to table, which table, guys? Okay, table A6. That's the answer. Superheated condition, superheated state of the fluid, of the steam. So with 3 megapascal, temperature 600 degrees C, then we get H3 as berapa? 3682.8 kilojoule per kilogram. If you're not very clear, I show you A6. This is A6. So A6, we want to have pressure 3 megapascal. Okay, and then with temperature berapa tadi? 600 kan? Ni 600. Temperature 600. Okay, so enthalpy dia adalah enthalpy yang keadaan kita pakai dia sebagai sini, enthalpy dia. Enthalpy-nya adalah ini 3682.8 kilojoule per kilogram. That's the enthalpy. So entropy everything tu ada sebelah-sebelah dia. We may extract the information. Let's see point 4. So point 4, the pressure is exactly 10 kPa. You know S4 is equal to S3. Kan? So S4 equal to S3. We know that the calculation for the value for entropy for fluid and gas, the mixture of it. We know the value for entropy for fluid. Macam mana nak tahu kat mana nak ambil value ni? And value ni adalah ambil daripada point 1 tadi lah. Sama je value dia. FF, SFG, similar to question A. Tapi S4 dia dah berubah lah. Sebab apa? S4 ni according to S3. So entropy pada S3 tadi ada, dia tunjuk dekat mana? Ni kat sini. Kan dekat sini S3. 7.5. So dia berbeza lah daripada yang tadi. X4 equal to S4 minus SF over SFG. S2 entropy, remember that. Then you get the value of I'm not sure how you calculate it. X4, and then you calculate for the H4. So H4 will become like this lah. HF fluid plus a fraction of HFG. And then the answer for this is, okay, I give you the answer. X4 is equal to 0.9 So make sure you calculate it, you get the H4. So you have H4, you have H3. Okay, now I believe we can start to calculate Q in and Q out. Okay, nak start calculation untuk thermal efficiency dah ni. Q in equal to berapa? Kat mana Q in? Ingat tak? Q in kat sini kan? Q in. Q out kat mana? Kat sini. Q out. So Q in H3 minus H2. Q out equal to 4 minus 1. H4 minus H1. So you put the value, and then definitely you can get the thermal efficiency for question B equal to 1 minus Q out over Q in. Then you get the value of 0.373 or 37.3%. Now if you realize the value that we get now is higher than the previous value, the efficiency, meaning whenever you have the superheated condition ataupun you add another steamer over there, ataupun macam boiler satu lagi ke, you superheat dia, tambah lagi temperature untuk masuk dalam turbine, efficiency dia meningkat. Right, this just prove to us on how can we improve the efficiency of Rankine cycle yang dalam teori kita belajar. Untuk question C pula, we want what is the difference at point C? The difference at point C, we increase the boiler. Ni tadi kan 3 megapascal, ni 15 megapascal. 50 megapascal in the boiler, and then ditambah lagi steamer tu punya pressure. So kita boleh calculate exactly the same steps. We calculate for each point. So point 1, I believe point 1 should be the same, remain the same with the previous question. Similar with question A and question B. Nanti ambil value dia. So point 2 pula, point 2 tak boleh sebab point 2 ni dia dah berubah. Pada point 2 pressure is tadi 15, sekarang ni tadi 3 megapascal, sekarang ni jadi 15 megapascal. Okay, and then S2 equal to S1. So bila 15 megapascal, S2 equal to S1, you do exactly the same step. Ingat tak step ni kat mana? Dia ada W pump in between point 1 dengan point 2. So point 1 dengan point 2 exactly similar. V pada 1, specific volume pada point 1 times pressure pada point 2 minus pressure pada point 1. So point 1 exactly sama kan, macam QA and QB. You akan dapatlah value nya kan. You akan dapat value untuk point 2. Macam mana dapat ni? W pump you calculate dulu. W pump. So V1 berapa tadi? Masukkan V1. Mana V1 kita? V1 kita adalah 0.001. 0.00101. P2 15 megapascal, maksudnya jadi 15,000 lah. Minus 10 kilopascal kan, ni 10 kilopascal juga question C. 10 kilopascal. So akan dapat berapa W pump? So please calculate W pump, kilojoule per kilogram, and then using the W pump we can get the enthalpy at point 2. Macam mana? Enthalpy at point 2 is equal to enthalpy at point 1 plus W pump. So finally we get the enthalpy at point 2 as 206.95 kilojoule per kilogram. How about at point 3? Okay, so point 3 pula, point 3 berbeza. Point 3 P dia adalah 15 megapascal. Temperature dia pula adalah maintain with 600 degree C. So nak buat apa? Kita refer to table lah kan? Refer table A6. We get H at point 3 as 34. Okay, you can get the value for apa tu? S3. Get the value for S3. Sebab apa? S3 nanti nak pakai untuk S4. Now for point 4, so point 4 ni nak calculate macam mana? Point 4 pressure is 10 kilopascal, kan? And then definitely dia punya enthalpy pada H4 kita nak calculate, tapi tak boleh exactly sama macam H1. Sebab apa? Sebab dia dah ada entropy yang tinggi. So S4 equal to S3, and then we calculate exactly similar like the previous one ini. Then because dia adalah saturated mixture, then we have to calculate for the mixture at point 4. So percent mixture at point 4 is equal to entropy at point 4 minus entropy fluid over entropy for fluid and gas, ataupun mixture of fluid liquid and gas, liquid and steam. So finally we get the value of X4 as 0.804. So knowing this, then we can calculate for H4. So H4 is equal to HFG. So HFG. So kat mana nak dapat HF? HF exactly sama macam HF pada point 1. HF pada point 1 kan 191.8 kilojoule plus X4 tadi 0.804. Lepas tu pada fluid dengan gas ataupun pada liquid dengan steam 92.1. Okay, then we get the value of apa nama dia? H4, which is, then we calculate for Q in and Q out exactly the same. Q in kita adalah H3 minus H2, Q out kita adalah H4 minus H1. So Q in adalah
so we get the value for Q in as 3376.2 kilojoule per kilogram. H4 pula adalah 1923.5 kilojoule per kilogram. Then we get the
efficiency 1 minus Q out over Q in is equal to 43%. Tengok 43% dah. Makin tinggi pula. Kan? Makin tinggi. Kita increase pressure kepada boiler, dia dah naikkan up to 43%. So initially dia hanyalah 33.4%, then increase to 37, and then whenever we increase the boiler pressure, we get up to 43%. Okay, I think that's all for this question. Thank you.